Thank you everyone for joining us today to learn about the Digital Reliability Center maintenance. My name is Jason Kurzel, Account Exec at Cortec.ai, and I'll be hosting today's webinar. Digitalization of asset reliability and maintenance holds a great potential to increase uptime and asset utilization and drive maintenance costs down. Despite the acceleration of technologies, the promise is not yet being realized. Aligning the use of new predictive technologies with principles of reliability-centered maintenance, RCM, preparedness with data and asset utilization understanding, and creating the right culture are keys to success. In the webinar today, we'll show how with the right preparation and use of RCM principles, valuable applications using advanced analytics and machine learning can be easily built by reliability practitioners to drive immediate value. We'll also discuss how this value can be sustained and scaled by aligning the culture with investment in technology. Joining me are speakers Dr. Klaus, Blache, Director of Reliability and Maintenance Center and Professor at the University of Tennessee, Cortec founder and CEO Rajiv Anand, and the Reliability Sherpa Ramesh Gulati. During today's webinar, please input any questions into the chat window and we'll answer them during our Q&A sessions at the end. Dr. Klaus will kick off today's agenda speaking about how well are you prepared for digitalization of your RCM practice.
Thank you for the introduction. Everybody's seeing what's going on with technologies, or at least kind of seeing the potential. But the question is, how do I get there? When do I get there? And what do I need to do? And how easy is it? Or in this case, how difficult can it be if it's not done right? So we'd like to talk a little bit about digitizing some of what needs to happen in reliability-centered maintenance, and are you ready? And what I see a lot of people still at is what I call the zone of uncertainty. I think we're about a year or two into that. Usually they last about 4 or 5 years. And we've been through several of those, even before our lifetime, as a lot of the maintenance has changed. And we'll talk a little more about that a couple of slides in. To get ready, here's just a list of things, just a sampling. To get ready for digitalization, you need to ask, what will the technology do for you? It's not just everybody doing it, so I should do it. Is it going to be a small or large impact to not just the formal, but really more importantly, the informal processes that drive your day-to-day operation, and how will the technology impact that, and how will the people accept it or not accept it? How is good is your data? I see people that have lots of data, but it's not that granular or just not that accurate. And I see other people that have really good data, but there's data missing. So that's still a challenge in too many locations. Will it change your current operations and how you currently run the business? How does the technology impact the employees? What they know, what they don't know, are they comfortable, uncomfortable with it? And how will it impact your competitive advantage, both currently and future potential, and how long will it take you to get there? And then how adaptive or ready is your workforce and for the level of technology that you think you'd like to implement? And as you go forward, there's many questions, but 3 that you need to answer. One is, are you selecting a technology level that fits your culture, or do you need to do something with your culture or your engagement, your employee readiness to accept that technology? And if the changes are big enough, you'll want to change or update your business model, and preferably in advance. And so it's showing that you're doing the process changes to kind of walk the talk as the company or group goes forward. Then the processes should still be focused around people, because again, the technologies that I see are really good. The issue is really implementation. It's implementation of the digitalization and getting the people to accept it and do it right to add value. And I think the benefits are there. Studies that I've seen from McKinsey's and other places, that those companies that really understand both the performance and operational side, but also focus equally as much on the organizational health, again, that's the engagement, the people side of the business. Those that find that right balance, they tend to see 30% more on the bottom line, like EBIT, return on investment, and so on. So definitely worth the effort to find that right balance. And why do you want to do this? Well, first of all, and what makes it difficult, because many times the people don't have the foundational things in place. And it can be as simple, and again, simply said, but not easily always implemented, is do you have a robust continuous improvement process? And through that finding and fixing, that also impacts finding and fixing things within the predictive technologies, condition-based monitoring, and the follow-up work. And from my studies that I've done in the past, and big studies in 2017, I revalidated it in 2019, that the top quartile in the United States, when I say top quartile, I look at that relative to reactive maintenance, because I think that's the biggest thing that you need to fix. Top quartile in North America averages 9% reactive maintenance, but they get there by averaging 23% of their resources by hours towards predictive or technology finds, and then another 30% doing the work orders to fix those finds. So they have their cycle of find it, fix it, find it, fix it. They're doing that continuous improvement, and they're getting rid of those repeat errors. If you don't have that, how do you get better? You get back to that old definition of Einstein's, that if you do the same thing over and over again and you expect different results, that's insanity. Well, if we don't have that continuous improvement cycle in maintenance, all we're doing is fixing the same stuff over and over again over a long period of time. And I call that maintenance insanity. That's no different. But again, those that are doing the right thing, they average 9% reactive maintenance. They're 27% in the OSHA recordables, especially those places that start out highly reactive. We're going to get a bigger benefit in safety. And again, the impact is also on throughput in the bottom line, looking at overall equipment effectiveness. Just the top quartile average 7% higher than the middle, second and third. That's the second and third quartile, and much higher in OEE than the bottom quartile. And when I go into a plant to do an assessment or just do a review and see how they're doing, there's three things I look at right away: is do they have standardized work processes? Do you have individual small team continuous improvement? Or do they have lots of groups of small teams wanting to make a difference on the plant floor, that finding and fixing? And do they have a methodology to improve and sustain the thinking process to one of ongoing improvement throughout the plant? Many times I get a lot of yes nods, often on all three of these. But as soon as I ask, and how well are they working for you? Even though we have standardized work, are people really following it? And you said you have a root cause analysis process, but find out that it's really an informal process, not really a formal process that does the follow-up and so on. So again, it's that kind of stuff that really hurts the implementation, not just in reliability-centered maintenance, but equally as much in implementing technologies. So when you implement technologies, I see that strongly as a socio-technical process. And that's a big word. It simply means you got to spend half your time on the performance side in technologies, but you got to have an equal amount of effort on the organizational health and the people side of the business. And if you don't do that, technologies will always struggle. We don't have time to go through all of this, and so we're going to look more at just the last several years. But the first half of this is pretty much what John Mowbray had in his book, or close to it. And you see, I put in there a bunch of different zones of uncertainty when people had to change their paradigms on how they think to do reliability and maintenance. It kind of starts way back from the fixes when it's broke to, I won't talk through all the zones, but I'm going to jump right ahead, 30 years plus another 30 years. You can see there's long periods of time. But now all of a sudden, this next zone of uncertainty is within 10 years. And we've already talked a lot, meaning industry in general, about precision maintenance making a big difference, and all the real-time data, big data, the more comprehensive analytics. There's people doing prescriptive maintenance where algorithms are helping make decisions, and they're making the work orders on things that you're programming it to do and enabling it the machine learning to do. A lot more coming out on edge computing. Everything won't go to the cloud. We know about that. Augmented reality and digital twins, some discussion on that, but I don't see that many practical applications. It's a lot of effort to get there, although it'll be good. Machine learning that we're going to talk about today and is tied to artificial intelligence. Also, I think good processes that can be implemented, but we got to get better at the people side of the business. And then as we go forward, again, we're going through the zone of uncertainty. How fast do I get on board? What should I do? Where do I go from here? I'm just trying to get production out every day. So the question is how do you integrate that asset management system? So it's how do you integrate it, and how do you make sense of it all collectively? Because there's so much going on around it and getting production out. And then on top of that, you've got to add value in a timely manner to make this work. And if you look on the bottom there, those first zones of uncertainty were 30 years, then all of a sudden it's 10 years, and we're in another one. The next one I think is going to come within 5 years. So again, there's so much changing so fast, and it makes things tougher to make decisions on. And we won't get into quantum computing or neural networks, but at some point, those just won't be game changers, that they'll be world changers. And things we still struggle with, even back in since 2010, North America told me that we don't get better at the people side of the business on the plant floor. Things like percent reactive maintenance are going to flatline, and I've seen that for the last 2 years, actually with data now. North America is not getting better on average in reactive maintenance, and we all need to get better at getting better data, and that will help us get faster out of that zone of uncertainty. So this is another study I was involved with, and I collected a lot of data for North America beyond the original study. And as you can see, it's a simple scale on the left-hand side, a 0 being no adoption of that technology at all, to a 4 being full adoption. As you can see, none of the technologies are past a 2. Machine learning is over there, just under a 1. And so everything is still pretty much in its infancy, at least on average from what I see across North America. And using that same 4-point scale on the left, this is just machine learning now here separately. You can see nobody's claiming full adoption, where they're comfortable with it, with everything. No adoption is half the responses, and you can see the responses as they get bigger. So again, why is this? The technology is great. I think the technology can help us, but it's the implementation that people struggle with. So with that, we're going to discuss, that people aren't optimizing. I mean, some of the reasons I see for this, people aren't optimizing the use of the PF curves. I think there's tools that can do that with machine learning as well as viable analysis. Again, I see companies that have phenomenal talent, but they don't make the decisions, the tough decisions day to day, because they don't trust their data. And it's, again, lack of data, lack of root cause analysis, continuous improvement tied to it, insufficient failure codes or use of them. So with that, we're going to present, and Rajiv is going to present, a tool that can help with that. So Rajiv.
Thank you, Klaus. So as Klaus said, so if we know about the promise and we know that this is the next mile, as Klaus said, and technology is there, and many of us are investing in this area, why are we struggling with that adoption? So from my point of view, first, it is not about technology. When we talk to customers who are investing, we hear all types of stories about the struggle to make a progress. And the stories range anywhere from, we've invested in an IIoT platform, but we're not able to build any reliability applications with it. And the other spectrum ends up being, we've invested in a lot more sensors, but our practitioners have even less time to analyze that data. And all we are getting is more alerts that we end up turning off. So first of all, it is not about technology. Second, expectations. Unrealistic expectations sometimes. Sometimes, they're set up by marketing and hype that is based purely on theory. This quest for prediction of failure. Unless your strategy is to run to failure, how valuable really is to have that absolute 100% accurate prediction of failure? I ask that question. You should ask that question. And unless you're doing a science project, how many assets do you really have the data, the past failure, understanding of the physics of failure to do a real RUL application? And even if you do, the investment and the ROI will probably disillusion you. And then there's misunderstanding and myths that all use cases require a lot of past failure data, and you need to be an expert in data science and machine learning. The reality is that you can build practical, usable applications with a good RCM understanding, like Klaus said, of failure modes, P2F curves, and a reliability-focused application, not an IIoT platform. And you can do this today. And I will try to cover this process fairly quickly. In our implementation, we have taken a risk-based approach rather than the subjective concepts of asset health index, et cetera. What is key and what makes RCM hard is the randomness and, even more importantly, the stress on the assets induced by operational variability, sometimes caused by humans, and sometimes it's just unavoidable given the nature of the product you make or the type of industry you are in. Incipient and latent failure modes and mechanisms whose trajectory can be completely random at times. That, to me, is where investment in advanced analytics, machine learning, AI, and digital is worthy. So if we start with those, or maybe only focus on those initially, on those applications, the ROI and adoption, in my view, can be much faster. You can get ROI, which gives you the confidence. You can sometimes even reinvest that ROI and move further. And we can get to making decisions based on risk, probability, and the confidence intervals. There's an adjacent field to reliability, which is safety. And in safety, most management decisions, and we know this, are all based on probabilities and confidence intervals and not absolutes. And particularly when you go after faults that are inherently, or failure modes that are inherently random in nature and are impacted by operational discipline, you can make a lot of progress with good probabilities, which is really a lot of what machine learning, not deep learning, is founded on. And you can make progress rather than focusing on some, chasing some unrealistic absolutes that may just be living in theory right now. So let's talk about the role of machine learning in this place, in advanced analytics, machine learning, when it comes to digital implementation of RCM. But before we do that, we've talked about risk, let's talk about risk a little bit more. As I said earlier, my definition or somebody else's definition of a health index can be very subjective. But the science of risk is universal. It is well understood. We do FMEAs and we assign severity codes to failure modes. It is detectability that has always been the challenge. In order to improve detectability, we first started using condition-based maintenance, CBM. First with route-based measurements, which we are still doing, and now increasingly by adding condition sensors. This is where machine learning comes in. The role of machine learning in this case is to first improve that detectability. First, as we all add more condition sensors, or we have existing condition sensors, creating baselines and thresholds is not an easy task. It may be easy if you are dealing with an always steady state, no operational variability type of process, but that is hardly ever the reality. With machine learning, you can have a model, understand, and create practically an infinite set of rules to baseline the detection technology like vibration or whatever you might be using under any number of operating states in a multivariate understanding. You can even get more from multiple detection technologies if you're applying them on some assets by combining them into a common model. And even more importantly, using machine learning to move that P point up the P2F curve. That is really the true next generation CBM that we would be able to build with machine learning. We have a wealth of information in our process operations, which largely, sometimes in many organizations, doesn't even see the light of day by reliability and maintenance practitioners. Particularly electrical data like VFDs that just goes unutilized. We don't even see it as a CBM technology just because we did not install one physical condition sensor. So what we can do today that is practical, usable, and drives our maintenance actions and decisions is what we can focus on. We understand and put in place P2F curves and intervals, but in reality, as practitioners, in reality, we make decisions and actions based on the net P2F. What is my real P2F right now, and what can and should I do? How is that net P2F evolving? How fast am I accumulating that risk? If we have these things, so if all these things are available, we can get to the possibilities of what is my loss of function risk and how quickly is that risk evolving? Which failure modes and mechanisms are starting to become more active? This is what defines my time in abnormal operations. When I'm running in conditions which haven't caused the failure, but are making a failure mode as detected by a failure mechanism active. This gives me a definition of the total abnormal time. Is this trajectory getting worse? With this, we can drive actions and we can get to value right now. So when you implement digital RCM using our platform, you follow this process. The complete workflow is pre-built for you. For each failure mechanism, you build an agent using machine learning or rules, and often a combination of the two. You can do this using our machine learning tool that is really meant for reliability practitioners. But if some organizations are investing in data science teams, they can build and deploy modeling libraries of their choice to create that agent. Once you have that agent, the pre-built application does the rest for you. It calculates time in abnormal operations, which really means anytime any one of those agents is active. Once again, active means it's crossing certain thresholds, doesn't mean you have moved down the P2F curve. It uses the rate of change of that time in abnormal operations to compute a net P2F so that you have visibility to the net P2F available to you to drive actions. And it then uses the occurrence, if you go back to that risk definition that I had, and it then uses the occurrence, which is the trigger of those agents, and combined with severity, it's computing risk to loss of function. So if you follow the RCM process and you combine it with the technology and the pre-built workflows, you can focus on outcomes and actions and results and get to that ROI. And Brian is now going to give you a short overview of how it all comes together. Over to you, Brian.
Great, thanks, Rajiv. All right, yeah, so I'm going to go through a demo of the Cortec reliability application. So here we are in the Cortec platform, and we're going to see how these digital RCM-based outputs can be consumed from an end user perspective. So I'll navigate into this reliability application, where we'll start with just a high-level view of my plant and the assets that I have configured for it, along with some of the key metrics that Rajiv was talking about, such as our abnormal operation time and our current risk, which is a cumulative risk across all the possible failure mechanisms that I've chosen to monitor. And then when one of those failure mechanisms trigger, there's specific actions that I may need to take to ensure the health of my asset tracked by these pending actions. So this gives us a good overview of kind of how much risk we have overall, where it's coming from. But now we want to dive in deeper into an individual asset, this hydraulic system that's contributing the most to my overall risk. So I'll drill into this, and we'll see a lot of the same key metrics on this screen. But now there's two main things that really stand out, are these two charts. So my abnormal operation time per hour and my loss of function risk index. So we can see how these change and accumulate. But more importantly, I want to see how this changes over time. So I also have this rate of change of abnormal hours trend, which is looking at the acceleration of degradation of my asset. So if you think about that P to F curve, how far to the right on that curve am I, and how quickly am I approaching potential asset failure that I need to take action to avoid? And that's really what that net P to F is that Rajiv was talking about. So here we can see these different instances of abnormal operation, but why did these trigger? What specific failure mechanisms are active? So I have different rules or agents that are set up and configured to monitor these. And based on the type of failure mechanism, we may need a different type of agent to detect it. So we have basic rule-based ones, that's just a threshold. So this is a differential pressure across a strainer. We have prediction agents set up to look at, say, a low cooling efficiency. And then we also have anomaly detection agents, which are based more on that baseline that Rajiv was talking about, where we baseline the asset and then look at real-time operation relative to that baseline for if we're operating normally or not. And if you think about that flow chart that Rajiv was talking about, where we first identify the failure mode, then the failure mechanism, in this case, internal pump leakage, that I want to detect, and then I've built a machine learning model for that detectability and deployed that model as a live agent to track occurrences of this failure mechanism. So I can see a breakdown of what data trigger this. In this case, an anomaly detection score went above a certain threshold. But if we want to dive a little bit deeper, what did the machine learning model actually see that led to this anomaly detection? What was different about this operation versus my normal operation? So for this, I can come into this model view, my internal pump leakage, and I can zoom in on a time period where I had one of these occurrences. And I can see these spikes in this anomaly detection score. And what this is the output of a machine learning model that's saying, based on my baseline, if I'm perfectly in line with my baseline, I get a score of 0. And if it's completely anomalous, completely abnormal, I get a score of 100. So there's this range. And where we see this trigger, we had some periods of high abnormal operation time. And then we can look at the underlying influencing factors that the machine learning model actually detected this abnormal operation on. So some pressures, some volume flow rates, some temperatures. So if I want to take a deeper look into what led to this abnormal operation time, what triggered this failure mechanism, these are the parameters I want to focus on. Next, I want to see, all right, when this failure mechanism triggers, what actions do I need to take? Is there anything I have to do about this to ensure the health of my asset? So that's what this action log tab is. I can come into my internal pump leakage again. Now I can see, saying the operator on shift should dispatch maintenance staff. So this becomes a log not only of the occurrences, but who's responsible for them, what action was taken about them. Now this is looking at just an individual occurrence, but I can also set up an agent to look at a collection of occurrences, starting to move towards that rate of change I want to look at. So say if this typically happens once a week and now it's starting to happen 10 times a day, that frequency of the failure mechanism is increasing. So I can set up a notification for this as well, where I'm monitoring the rate of change of abnormal operation time for my asset, my hydraulic system. So based on this notification, this is just saying, hey, something's wrong. Then I can come back into my action log and see what's actually contributing to that rate of change of abnormal operation. So I can see I have this high occurrence rate for internal pump leakage, which is linked into this soft tag for abnormal operation time rate of change. That's how I know that is linked. It's all linked in the back end. And because this is accelerating, we know the risk of failure is also accelerating. So now this is more urgent and we want to take action on it. So we're able to, say, come in and investigate the data, which is supported by those influencing factors that we looked at earlier. And now we're saying, in this case, physically open a work order in the CMMS system manually, but that can also be automated through direct integration with CMMS systems. So we could go one step deeper and actually look at the creation of these machine learning models that were created to detect these different failure mechanisms. But this is how deep we'll go today. We can always have follow-up sessions if you're interested in seeing how those models are built. But hopefully this gives you an understanding of how we can go through this digital RCM workflow using the Cortec reliability application, beginning with our asset data, building machine learning models and rules on top of that data to monitor the important failure mechanisms that we've identified, then track those failure mechanisms to see how they contribute to my overall abnormal operation time and ultimately asset risk, so I can ensure the functionality and health of my asset and overall process. So that's all I want to show for a demo. Hopefully that gives you a pretty good idea of how this all works. And next, I'd like to turn it over to Ramesh.
Okay, all right. Are you ready for effective implementation? Anytime you want to make a improvements are change. And improvement is a must for any organization in today's environment. We are globally competing, it's fast moving. And improvement are best practices, such as RCM, dRCM, and those are change. And it's not easy to implement a change. I have been over 50 years spent in the industry and implement those changes. I've found they are difficult to implement those changes unless until you have right culture built in. Also, we need to know there's not a small or large depends upon your culture, if your people are ready to change and adopt the new environment. If they're not, it will be difficult to implement. Majority of improvements projects don't deliver expected results. I have seen that 70% of this data come from surveys at the International Meters Conference and other places, that 70% or more RCM or PM improvement projects fail. They don't deliver required results. Why do they fail? It's a lack of understanding, knowledge about change, unclear objectives, and a quick return. In fact, I have tried RCM back in 80s, failed, didn't work out. I was ready, but people who would implement change were not ready. Then I tried it again. It failed. Then mid-90s, I tried again, we tried. But by that time, we realized we had to build a culture. We did that, and then it started working. So, and also, a lot of time our top management or financial people are looking for quick return. Implementing reliability is a journey. It takes time to build a culture and make improvements. Then also, you may not have the right resources. As I said, the key thing is establishing a conducive right culture. And if your culture is not ready for change, boy, it's going to be very, very difficult. And it takes time to build that culture. This change you want to bring, the improvement you want to bring, you have to change the people's behavior. How people behave, you have to create a vision, what's good for them, how it's going to help them. And once you start changing their behavior, their habits, that change becomes a way of life and becomes the part of a culture. Excellence is a moving target. What was good enough yesterday is not good enough today, and it won't be tomorrow. So we have to do a continuous improvement all the time. We have to change people's mindset and create this culture of improvement in our people. They need to understand, why this change is good for them. We want to do RCM. We went through that. As I said, we failed a couple of times. I had the best people, consultant, author with me, but we failed till we got in the culture part where people really understood how this change is going to help them. Sometimes we need to create a burning platform to speak. How this change is going to help them, how this RCM process is going to show improvement and their life will be easier. What's for me? Anybody who's on the shop floor or who's ever doing their job, how this change RCM process is going to help them to do their job better. We need to educate stakeholders, including the management, what the overall process is, a big picture. And then we have to look by role, sub-process. We have to educate people, train them so they understand this change is coming, how it's going to help them do their job better, and their life is going to make a difference in their life. Now, some people say, hey, let's make a big change. Now, I have found making a small step, take a small area, try to have a prototype in that area, show people small changes, and then implement all our other places. Okay. Again, as I said, building reliability is a journey. It's not a program. Otherwise, if people don't understand, it's going to become program of the month. Hey, it's going to be next month something different. it is a journey. It takes time to build this. You must be the change you wished in the world. You have to become a role model doing, hey, yes, we're going to implement change. I'll tell you one example. Many years ago, a few years back, I was driving somewhere. I was going on a meeting and I got a car. Rent car, wanted to go there. I got the car. When I started driving, this was Toyota Yaris car. I found my dashboard was missing there. Dashboard was moved from the center. Nobody told me. Those 20 miles were so devastating for me because I was moving my head like this. I could see my dashboard, what mile speed I'm driving. That was a big change for me because nobody told me about it. Somebody would, yeah, I can see later on, hey, they want to reduce the cost, but nobody consulted me, told me this is going to happen. That Yaris no longer there. Is they have moved back dashboard in the center, or in fact, all your new electric car, at least they give you something in the front of your steering wheel. So change, you must accept that change. I need to know what change is coming, how it's going to help me. Brian, Jason?
Thank you, Ramesh. So just to add a few conclusions from today's webinar. So from Klaus's point of view, being prepared for adopting technology should be part of a continuous improvement process. And that process should still be focused on how prepared those people are. And AI and ML technology may still be in your zone of uncertainty, but it's still inevitable and imminent as part of your RCM practice. From Rajiv, today you can build practical and high ROI applications by your practitioners, and you can focus those actionable outcomes like the net PDF and time in abnormal operation within those applications. And a big key takeaway from Ramesh is, in order for these things to succeed, having and building a conducive culture is key to effective implementation of improvement projects such as digital RCM. So this concludes our webinar content today. We hope this session was informative, and if you'd like to discuss any specifics, how we can help with your digital RCM practice, please reach out to any of us and we can have a deeper discussion. With that, I'd like to thank you again for joining us and have a great day.